And well, please notice that all exercises here have sets and subset ideas. So we have this pair of symbols that they want to utilize in all the problems. So whenever you put so-called elements inside the braces, so you're gonna get a set, like in exercise 1, I have set of 3 elements, 1, 2, and 5. And the other set looks like bigger set that contains the elements 1, 2, and 5, and a little extra stuff. So I can utilize the symbol of a subset then, right? So I can say that 1, 2, and 5 is included, is a set which is included in the larger set. And looking at problem number 14, I can see that empty set is also going to be included in a set of elements 1, 3, and 5.
Professor, sorry to interrupt. Can you explain the difference between the exercise 41, 43, and 45, please?
Sure.
The Ralph, please. Thank you.
Absolutely. So exercise 41 has not set in here because the Ralph does not have braces around it. And in exercise number 45, we have a set because they put that name inside the braces. So whenever you have a set, then you can start to treat it as if it was a subset. In other words, the Ralph in the braces is a subset of this larger set. So in 43, since we don't have braces, then we don't have a subset, even though that you see that name among the elements, but it is not correct to call it as a subset because it is not a set. So the idea of word subset is that whatever we have as a subset has to be a set on its own. And if it's not a set, then we can say this is just an element. So it's a notation. So it's not, I guess, something that one has to remember all the time. But the point of story is that to be a subset, that entire thing need to be a set. So if it's not a set, it cannot be a subset. That's an idea for this exercise. In other words, for example, if you have 42 problem, then Canada is an element, yes, but in exercise number 44, Canada is not a subset because it doesn't have braces around it, so it is not a set itself. So to be a subset, this needs to be a set on its own. So that's all they trying to show in those exercises. So for example, in problem number 49, 5 that they put inside the braces is a set on its own, so it cannot be an element because it's set itself. So it's a little bit fuzzy, I know, but that's really all they want you to realize. So you want to look at example 2. Thank you for reminding me. That's very good. So we looked at the example 2, and that example had 3 elements, 2, 3, and 7. And I can see all of them in here. So if you are dealing with the symbol subset, then you can say that, yes, these 3 elements are producing set. So it makes sense to say that this is a part of the larger set or a subset. So that's exercise 2. So that's pretty much all this section is talking about. So maybe I can move on to the next section and see what else we can deal with in here with those sets and their elements and subsets and so forth. So here I'm going to start with section 3 of chapter 2, which is dealing with those universal sets. Oh, I think that we already started with them. That's now I recall that we had, I think, a quiz on the next section, right? So in example 2, now I can recognize it. No wonder I couldn't find it because there was no session exercise in 2.2. So we started last time to talk about section 3 of that chapter. So let me recall what is going on here in that example. So I think for a quiz, I asked you to do something that relates to example 2 in that page, right? So let's see, what is that we had to consider in here? And I believe we had to find the elements of set A, right? So set A, which is up here, is the set that consists of 4 elements, looks like. It has elements A, B, C, but also D, which is the intersection of sets A and B as well. So there are 4 elements that one should have just put in a set A. So what we have here is a so-called Venn diagram, and this is designed to just help us better understand and get more intuition into what is really going on with the sets. So it's always helpful to produce this little diagram. So other thing, what they are talking about here is so-called the complement of the set. And the complement means it's everything that is not in your set A. And they have a special symbol A prime for that. So it's a set of all elements that are not in A. So for example, if I want to look at my previous case and think of what A complement is going to contain, well, then if you imagine yourself a picture that looks like that, so everything that is not in a set A, and this will be E, F, and G, so everything from this so-called universal set, so that's a universe for this particular example. Remember, it doesn't have many elements in it, just 7 of them. So if you already declared elements A, B, C, and D for the set A, then what is not in A will be everything that remains, everything else. And that's what we have here. So anyways, we have so-called complements, and now we probably can take a look at the exercises in this section. and just to enjoy some of those little problems. I think those are nice little problems in that. So let me go to the exercises part here, section 2.3. So I can clean this a little bit. Get rid of this. And we can start with our first group of problems that actually wants to decide on the universal set for the exercise number 1. So let me start with exercise number 1 that talks about sets A and B that seem not to have anything in common, right? So we have a whole bunch of composers. So the first has 3. So it has Bach, Mozart, and Beethoven. So it's a first set. And the second set consists of 2 other totally different people. So we have a picture of completely non-intersecting sets, or people sometimes call it as mutually exclusive. And all 5 of these names will compose the universal set. So if you want to put universal set, you need to list all these 5 names. So you can definitely do that. So I would say producing Venn diagrams is a very helpful type of procedure. So let me try to do this for exercise number 9 as well. So in this exercise, they have set A that consists of numbers 1, 2, 3, 4, and a 5. So that's our set A. And then they also say there's a universal set here that has all other numbers up to 20. So they're talking about 6, 7, 8, etc., all the way to 20. So if someone wants to find the complement or whatever is not in set A, then what you do is have all of these remaining elements that start at 6 and go to 20 in that particular set. From 6 to 20 is what we have. So it looks like those are complements of the sets that we can consider. And of course, for any exercise in this group, it's pretty much same process. If you're not sure how to get it right away, well, make this picture of Venn diagram, and this is definitely going to be very helpful. So how about exercise number 67? So I'm gonna try to find set A from given Venn diagram. And to be able to see what elements this set has, well, I can just highlight it and get to that a little bit closer and see that it actually consists of elements 1 and then 4. That's from my set A, and a couple of more, such as a 3 and a 7 from the overlap of sets A and B. And of course, I'll put commas in between of those elements just to make sure that everyone can clearly see what is going on. And once again, Venn diagrams are very helpful because they give us intuition into what is going on. Let me say, Alex, what does this symbol stands for in exercise number 70? So turns out there is so-called union of two sets that they provide us with here, A union B, which means that they're talking about everything included in either set A or in a set B. So if we consider the exercise 70 and relate it to Venn diagram that appears here in this example, then what I can do is take all of the elements from set A or from set B and put them together in one bigger set. So it's going to have N1 and 4 and 3 and 7. So everything we had for the previous exercise, but also there will be 2, 5, and 6. So these are elements of our union. So there are so many of them in here. So actually have 1, 2, 3, 4, 5, 6, and 7. If you want to rearrange them, you'll still get exactly the same set. In fact, it's good to realize that if you rearrange the elements of the set, nothing's going to change, and you could do that just for convenience. How about exercise number 71, the intersection question? So what is going to be the overlap or intersection of those two sets, A and B? Well, looks like it's nicely highlighted here for us, right? So that intersection consists of only two elements, and they be 3 and a 7, and that's it. 3 and 7. So unions and intersections are here. Try to put some a little bit nicer. So how about if we try to find the complement? Let's say if I try to find complement in the exercise number 74. So what would complement of that intersection stand for? Well, looks like to get a picture of that, I need to highlight everything which is on the outside of my overlap in here. And this complement, this little prime here, right? We're gonna produce from placing 1, 4 in it from set A, also 2, 5, and 6 from the set B, but that's not it, because there will be more things such as element 8 and element 9 as well. So we're going to have so many elements in a complement of that intersection of sets A with a B, the complement. We say, how about if we try to do a problem like number 77 then? What if we try to find the intersection of A and a not B and a complement of B? How would that look like? And once again, I think the picture will be the best idea for that. So if I try to, first of all, recall what intersection stands for, so let me make a picture of intersection of two sets, A with a B, then I'm going to be taking a first set and a second and do something like that, right? Intersection. But how about if I try to intersect A with not B? How would that look like? Well, the answer is I need to look at everything that is in A, but outside of set B. outside of set B. Not in B means outside of B. When you say, so you're gonna also consider 8 and 9. Well, they are in the complement of set B, but they're not in A. That's why I'm not gonna touch those. I need those elements that belong to A only and do not belong to the set B. And this is gonna be a set of only 2 elements that I just highlighted here that belong to set A, but do not, at the same time, do not belong to the set B. So that's exercise 77. You say, okay, so how about problem number 78? That has, looks like similar pair of sets, still A and not B, but take their union. So what should we think of? Well, union means everything which is covered by either not B, and not B is here, outside of B. So highlight that part. It's set not A, not B, right? Or by set A, which is going to be also continued right there. You see? So this is going to be the set that I have to list. And notice that the only 3 elements that are not come into this union will be 2, 5, and 6. The ones that belong to B, but not to its complement. So let me put all the elements here together. So I put 1, 4, 3, 7. So that's my set A, right? Because I have to take a union of that one. And from not B, I'm gonna add a pair such as a 8 and a 9. And that'd be it. So we found the union of those 2 sets. How about that? So using Venn diagrams is a very popular way to understand, to better understand what's in a set and what's not in a set. So how about if you try for a little quiz, exercise number 73, and tell me what is not in the set B. And let me clean this a little bit so you can better see the set B here. So what is in the complement of the set B? What is not in the set B?